right, so remember, we should have the whole plan book filled in, so I shouldn't really need to stay on here very long. We're taking a mastery on Friday. Guys, I tried to give away my class to a different teacher and not teach on Friday and push the test to next week. They wanted me to do my job. So they're like, nah, you got to have class. But next week we have Outsiders Day, so you will get a day off of math next week. Go ahead, Lou. All right, so on 2.2.5 on the back, quick reminder in A that these are absolute value bars. What do absolute value bars do? Aiden?
So those are positive, and absolute values change those to a negative, like the opposite of it.
Trap door. That is not what happens. So this is why we're talking about this problem. Absolute value, guys, you should make a note on your paper if you don't remember. Absolute value is distance from 0. And guys, this is about to be on Masteries. 225, yes, 225. We're popping back here for a second because we had a question asked. Guys, always ask questions. Like, I'll go as far back as we need to. So, distance from 0. Distance is always positive. So, it does not do the opposite, like, unless the number's negative, and then it becomes positive. But don't tell yourself opposite. Tell yourself it's positive. Distance is positive. So distance from 0, always positive. So this actually doesn't have any impact because 10 plus 2 is 12, and it just stays 12. So then, guys, what it's testing, if we can do here, what it's like checking on, is can I make 0 pairs, right? Can I think through doing 0 pairs? So my positive 12 cancels out 12 of the negatives. So essentially I take 12 away from 32, and we get a negative 20 as our answer. It's wanting me to do the same strategy over here by recognizing this is a negative 1/3. It's also got a 50 in there, but we'll come back to talking about the 50. So that's a negative 1/3, and this is a positive 1/3. A positive and a negative of the same number cancel each other out. So those fractions, they just like disappear. Now, the 5.5 is still here. We'll deal with that in a second. So then if I have positive 17 and negative 50, same thing we did over here, except now the, well, actually, it's pretty much the same. So 50 is bigger. We take 17 away from it. Guys, I start by taking the 10 away, then take the 7 away. All right, so 50 minus 10 brings us down to 40. Minus 7 more brings us down to 33. So these two numbers together. But remember, it's negative because my negative here was stronger. So I got to remember to bring that down and make this negative. I still have a 5.5. Is this positive or negative? Yeah, because like that, you guys are all hesitant to answer because we can either call it minus 5.5, or what I like to do is say and a negative. I like to say plus the negative number because this is either a minus or a negative. So I got a negative and a negative. They team up, right? 38.5 because they team up, but it's negative. I will leave C for you guys to do, or come see me if you'd like to talk about that. Let's look at 226, last night's homework. This stuff should be done because we did it in class. I want to talk about 102, and then I'll actually put the answers up here because I don't want people just copying down answers. If you have not done 102, or if you didn't do it following the directions, they didn't use the bad word. But I think fast is that's probably like the F word. See, I said the F word and people are like, oh, what? Yeah, that's also probably a bad word. Guys, there's no goal of fast here, but some strategies will let you do mental math, which is quicker than typing into a calculator. So fast does not mean we're in a race, right? It just means, oh, if I do this in my brain, it's a bit easier. Guys, this is cross-reducing. Watch, I'm going to solve this, and I'll give you time to copy it. Don't worry. 5/6 times 24. I can make this a fraction by putting it over 1. Right? We said we can make any number a fraction by putting it over 1. But 5/6, what that's doing is multiplying by 5. And, guys, put your eyes up here. I got some people not looking, and it gets confusing if you're not looking. We are multiplying by 5. And, guys, this, I'm going to make it a different color. This is division. Even though it looks like multiplication, and it is multiplication, multiplication and division are the same thing. It's just what it does. Are we multiplying by 6 because I want 6 pizzas, or am I dividing the pizza by 6 because I need to feed 6 people? This is division by 6. Or you can call it multiplication by 1/6. Right? But what it's asking us to do is go ahead and do this because it's slightly easier because it makes the number smaller. And then we'll make the number bigger. So we want to do 24 divided by 6 first, and then we'll multiply by 5 because then we'll get bigger. What's 24 divided by 6? 4. So this is 4. The 5 drops down because we haven't used it yet. And what's 5 times 4? 20. On the back, let's do the next one together. Guys, these words are not just words. They're directions. Right? And the deeper we get in the school year, like, I will check your practice to see, hey, did you actually follow the directions? Because it's what I'm going to test you on. So if you don't know how to do these strategies, it's a little challenging. I'm going to show A in the cross-reducing way and write it out like we did yesterday, and then I'll probably write it again. So here, if you want to just watch and then copy, I'm going to do 3/4 times 24 over 1. What we actually were doing on the front. Huh? Nice. What we did in class yesterday, right? We circled both of these and said we can, what was that word we wrote down? Cross. It's not multiply. That's the trap door because everyone's brain, when you hear cross, they're like, oh, cross multiply. No. We're cross-reducing. So if you want to write this down again, we're cross-reducing. Oh, my name is cross-reducing today. So we divide by whatever we can. So 4 can divide by 4, and 24 can divide by 4. 1/6, and it becomes 18. The other way they did it on the front was to break it up and say, okay, this is really 3 times 1/4 times the 24. Because 3/4 is really multiply by 3 and divide by 4, but I don't want to write division. I like the multiplication dot. It's nice and quick. So then, what is 1/4 of 24? 6. It's this number we just got over here. So then it becomes 3 times 6. And it's the same thing. Trying to use all of the colors. And it's taking some time. Sorry, that does not look like an 8. There we go. So in B, the quote-unquote quick method they wanted us to take. Guys, I got some people that I keep looking around the room and we're not looking at the screen, so please make sure we're looking up here because, guys, I'm doing your homework for you. 32 divided by 8, right? This is what they're trying to kind of get us to get in that habit. What's 32 divided by 8? 4. So this is really 3 times 4 because what I highlighted became 4. So B really comes out to be 12. Guys, my alternative, if I don't take this shortcut, is to do 3 times 32, which is 96, and then divide 96 by 8, but I still get 12. It just makes me use bigger numbers, and I don't want to. I don't want to use bigger numbers. What? I just don't feel like it. Look, sometimes we're almost at the end of the quarter. Sometimes you just don't feel like it. So, what's 35 divided by 7? 5. So this really becomes 4 times 5, and it's 20. Because we can do the division before we do the multiplication, because they're the same thing. Whoa! He said it. And then down here we had a question about the graphing one. All coordinate points. I will come back to that because this question already, like, somebody came to me before class and said, hey, can we talk about this? All points, coordinate points, are ordered X, Y. Meaning this, your x-axis comes first, and the y comes second. So let's take like C, for example. If I'm going to negative 3 4/7, I'm going to zoom in for a second. Negative, I'm at negative 3 4/7. I just got to guess, guys. This graph is not perfect. So negative 3 4/7 is like right here, right in between the negative 3 and the negative 4. But then I got to go wherever the y tells me to. And the y tells me to go to negative 9 3/10. So my y is my vertical. So I got to go down, negative 9 3/10. So probably be, I don't know, there. And then we label it, that is C. Yeah. Label each point with its letter. These are not just words. They are instructions. I find it humorous when I look through your guys' homeworks and I can tell, oh, you definitely didn't read instructions. Like, you made this harder on yourself. Not you specific. I mean you, the greater you, the royal you. While going on a field trip, a bus load of 54 students will have to be split. Ooh. What does split tell us to do? Divide. So we're going to split into 3 groups. 2/3 will go to lunch first, and 1/3 will go visit the exhibits. How many will go to lunch first? So I could either figure out the 2/3, or I can figure out 1/3 and double it, right? This is trying to make us think about the strategy we were using up here. So 2/3 of 54 is the same thing as doing 2 times 1/3 of 54. Well, what's 1/3 of 54? Or 54 divided by 3? It's a little tough. We might not. 18? Yeah, that's a big one. That's not even on our multiplication table, right? So that's a tougher one. But this, if you want to group it, go ahead and throw some parentheses around it. This becomes 18. So 2 times 18. So 18 is our 1/3, right? So now I got to double it to find out how many go to lunch. 36 go to lunch. Probably, but you'll definitely be able to use your multiplication table. I'll give you that guarantee. I try to keep my numbers below 15, like, because the table goes 15 by 15. Yeah. Other answers, I guess 101, I should probably show you guys the answers for. So 101, if you have questions on, please ask. In 101, back on the front. Sorry, we kind of bounced around a little bit. Back on the front. A is just 2. Because it becomes 4/3 times 3/2. B is 8 1/3. Or, what's the improper? Anyone have the improper fraction? 25/3. Or, yeah, you might have something over 6. What is it over 6? 50. Just 50, right? So 50/6. Yeah, that works too. You're going to need to check your math. It's definitely not 6. It's 8 1/3 if we go to the mixed number form. We can go over it if you... John, you want me to go over it? Sure. Sure, he says with a delay in his voice. Which I like because I think maybe you're thinking about what went wrong, right? You're trying to track down your own mistake. So in B, when I go improper, 3 times 3 is 9, plus 1 is 10/3. I'm just going to do my work up here because I don't really have a ton of space down there. 2 times 2 is 4, plus 1 more is 5. So 5/2. So check your impropers. Then we multiply straight through top, straight through bottom. There is a new thing up on our dry erase board. When bad words get written, they get, censored. So if you need that reminder when you're doing work in here, check out the dry erase board to remind you how to multiply your fractions. C, 6 1/4, and D, 3 1/8. Anyone need either of those, Dikshita? What do you mean the first one? Be more specific. A, like 101A? Okay, this one. Let's do it. Oh, 12/6? Yeah, that is 2. So this becomes 4/3 times 3/2, right? When I make the... Ooh, you can't see this. Sure, we can do that one too. 12/6. Guys, especially because we have a mastery today, I want to make sure... Or today. This week... We do not today. This week, I want to make sure you're comfortable. So it's fine that we're taking all this time on homework. This is totally fine. Practice is the most important thing. You said you want to double check C? They're both the same, so this one's kind of fun. If I figure out the first number, I've got the second one. So 2 times 2 is 4, plus 1 more is 5/2. So the next one is also going to be 5/2. So we get 25/4. Yeah, which is 6 1/4. D, might as well do it because we're here. Yep, might as well do my homework for me, Mr. Hudson. Uh, 25/8. Is this one of the reasons why your parents think I'm weird, Antonella? Because I do your guys' homework for you?
No, I haven't told them that. They're probably going to be like,
Antonella came to me after class and she goes, "You know my parents think you're weird?" And I was like, "Well, lots of people think I'm weird." I'm like, whatever.
I think you're weird. In a good way.
I think we're all a little weird.
Yeah.
All right. So, on to, new section. On 2, 3, 1 now. Let's get out 2, 3, 1. Probably. Yeah. Hey, we don't need any animal noises. We are not at the petting zoo. Hey, friends. Remember, we're on the same team. I want to help you out, but we're not going to spend long on this. So you need to write this now, and then we're moving on. Down here in 115. Down here in 115, the reminder I want you to write yourself for scaling. To scale, because people keep coming and asking me about this, or I'll get a darker color to write in. What we do is take the distance and we divide it by the number of gaps. or jumps or whatever you want to call it. So for instance, here, which is always a problem that we think is difficult, how far is it from 0 to 1? 1. Right? From 0 to 1. No trick question here. So it's a distance of 1 divided by how many jumps? 1, 2, 3, 4. And then I count by that number. So my first gap is a fourth. My next one is 2/4. My next one is 3/4. And 4/4 gets me where I want to be. But reminder over here, you're going to have to subtract first. To get the distance here, if we don't start at 0, you got to subtract first. All right. Sweet. On your notes, I gave you a reminder. We're like not doing this today. We're pretty much going to be working on graph paper today. Sorry, I scooted too far. This is your reminder. For sure, you could do all of the work we talked about yesterday, or you could make the fractions improper. Come on, focus. And multiply straight through the top, straight through the bottom. Wham, bang, boom, we're done. I think this method is better because it's that's the easy method.
Just say the better method.
All right, the better method.
That's about difficult method.
Not as difficult. Easier, right? I guess easier. I could have written that because that's not a bad word. All right, so today we are practicing scaling our axes. You do need out that resource page still. If it's on the list of things to get out and you haven't used it yet, please keep it out. So if you don't have this out, get out the resource page with the rectangles on the front and the graphs on the back. This is what we care about today. These graphs on the back. The front has the rectangle split up. We need to be looking at the back. Are they? Yeah, those are supposed to be there. All right, anyone want to read? Because Peyton loves bats. Kylie, and I still owe you lifesavers. They're up here. So go ahead and read about Peyton's bats. Carmen. Sorry, I was trying to find my extra copy of this handout, which I finally did. So, let's just make some observations. And by the way, for anyone in here who's like, ooh, bats are really important because they eat bugs, right? So if we didn't have bats around, we'd have way more bugs. I don't know about you, but I don't like bugs. So, we've got all this data, right? Here's your objective. Work with your team to decide how Peyton can use this data to predict the wingspan of a bat if she knows its body length. So I want you guys to just chat, compare these things. What relationship can we try to make to like anticipate, oh, if a bat is 10 inches long, like what would its wingspan be? Or what if it's 8 inches? Or what if it's 6 inches? So chat with your team. Yeah, I hear what people are saying. What if I make the numbers not nice and I give you a bat length of like 43 or like 16 or 15 or 13 and not nice numbers.
Would you do that?
Oh, I would totally do that.
Does that make sense?
100%.
So since she's trying to figure out which is this length is 6 without to expand it, the length and
Is the wingspan bigger or smaller? What are the two ways in math we can
so
get
right now
right?
wingspan is that
So, which one looks like it would be more appropriate?
length and wingspan.
Is the wingspan bigger or smaller?
Now you want to figure
Bigger.
out
How can we get bigger mathematically?
so right now 6 how long would it
Okay. Like a little, sorry, a little with a double 5. Okay. Double 3 5 would be 7. Okay.
What about
Yeah.
yeah.
Looks like a 7. Is that the Brazilian? Add 2 Will you say that louder? Hey, I can't clap anymore because I broke myself. So, Lucas has a really interesting idea here.
For the big brown bat, Indian bat, and Indian bat a little bit, if you add 2 and then multiply times 2, you will either get really, really close or the wingspan.
So, guys, one thing that you're going to start to do more and more with math as you get like into the higher grades or whatever you want to call it is like just observe and kind of play with numbers. Like, how can these numbers relate to each other? You don't have to be good at this. It doesn't make you smart or not smart. It is impressive that Lucas just kind of thought this up. Because what's 5 plus 2? 7. And then if you double it, 14. What's 4 plus 2? 4 plus 2? 6. And then double that. Oh, it's real close. 3 plus 2? 5. Double that. So what Lucas is saying is take the length, add 2, and then double it. Okay, but I'm not as smart as Lucas, or I'm not as quick, I guess we should say, because it's not about smart or not smart. So I decide I'm going to put these points on a graph, right? So look at that paper that you have, and I will apologize, the printer did not really print your axes out, so you might want to make these darker real fast, so you can kind of see them. You got to make sure you put the point at the right place. So this axis and this axis. So if this is how Peyton graphed it, it's missing something. Not only did the printer not print out the axes very well, what is this graph missing for us to actually be able to use it? Labels, right? This graph is like naked, right? It's like a number with no labels. It's not appropriate, right? We said naked numbers are not appropriate. Unlabeled graph is not appropriate. Figure out, is this the x-axis? Is this length or is it wingspan? So go and chat with your team. How can we figure that out? Now you might need to see this again. So you might need to see that again. Just close enough to the wall. I can't walk through it. Just for fun. That's awesome. Not for no reason. Those are like measures of center because they normally tell us something about the information. Really good questions, guys. Really good questions. Let's label. This is X. This is our X. And this is our Y. Really good questions, those people that I heard discussing that. And then anyone, I could do cards, but I'm one-handed. Anyone want to volunteer to tell me how you figured out what's what? Yeah. So, wait, sorry, say that again. I got really distracted by whoever was tapping and making noise. I think I heard what you said. The X is the length because it's the smaller numbers. You guys look at like my X values only go to like 3 and like in between 3 and 4 and 4. Like this axis must be my small numbers, which in this situation is the length of the bag. So let's go ahead and put length. And Wingspan is what this is called, which actually is a really cool game. Anybody's family bought Wingspan yet? It's a sweet game. It's about birds. You build birds in 3 different areas. Yes, I'm a giant nerd. I play games about birds. All right, so Peyton has this idea, and she's like, you know, if I like draw a line. You guys have done this in science, right? Were you trying to draw a line through your points? No? All right, so here's the goal. If I look up here, please. I'm like running out of time, and I'm very aware of it. If I draw a line like this, does that match my data? No. If I draw a line like this, does that match my data? No. So try to draw the best line you can that cuts through as many points as possible. It's probably like that. I'm going to use a pencil so it's not so permanent. Whoa, we don't need to use the word hate in here. There are lots of bad words. All right, so there's a problem, though. Peyton needs to be able to predict, and she needs to be able to use this graph to predict the wingspan of birds between 10 and 20. Hey, give me your eyes up here, please. Unless you're chatting with Miss Martin, which obviously she's as important as me. Guys, if I am looking at lengths between 10 and 20, can I get to my line? Crap. My line is like way steep, and that's a problem for me. Anyone know how we could fix this and like... Yeah, but there's like words and stuff here. You're right. Like if we were working on graph paper, we could just like keep drawing the line further, right? But this is not graph up here. What if, since my wingspan like is a little bit closer to the axis and my length is really far away, Antonella? If we make, and I don't know if this is exactly what you meant to say, but it is what you said. If we make the y-axis the length and put the wingspan on the x-axis, guys, right here in 108, let's switch it. Let's, instead of doing length, let's do wingspan down here. And let's do length over here. This is why we practiced graphing on last night's homework. I'm going to bold up my axes. And then you guys probably need the data again, don't you? All right, there's your data so that you can graph. Please be careful of what's what. Your length is your y now. I know, because you need the data. So, this... Guys, this is going to mess with you. This is your x now, and this is your y. So the point we're graphing is 14, 5. Like, that's our first point, because we're switching things around. So for 14, 5, like my x is 14, my y is 5. All right, now I'm throwing things. Okay, now I've lost it.
Check the trash can.
Thanks, Layla. There was some excitement in my classroom this morning. Gravity was being gravity. So, oh wait! And we changed our numbers. If you don't want to match these numbers, if you don't want to be stuck fitting in their graph, you can make your own graph down here. And we can even make our own graph right here or on graph paper. Sorry that you can't see the axes. These graphs, at least on this paper, looks kind of annoying because there are axes here. You just can't see them. See the arrow? You can kind of see them. But yeah, so if you want to make your own graph, we can do that. Yeah, I'm just not quite sure. But let's go ahead and try. Sorry, you can't see the data. There you go. So 14, 5, 10. Sorry, I'm trying to make it so you guys can see both at the same time. Ooh, man, 2.35. That's kind of hard to... Because, guys, this counts by twos, right? Every box going on the x-axis is 2, but every box on the y-axis is only 1. So this is like right 2.35 and 12. Oh, no, I did it backwards. Hold on. The third one I was about to do backwards. Remember, we're doing the second number first, so the third one there is 12 and then 2.35. So that's actually like here. 11 and 4. 11. Man, these are still really like tight together. 10 and 3. Man. What could I do to get these points to be not so tight, like on top of each other? I already did it once. I want to spread things out. I need to spread out my numbers. If I want to spread stuff out, I can make the scale whatever I want. So if I space out these numbers more, maybe make 5 like all the way up here. Now I can't change this graph because I graphed in pen. Right? But if I scooch 5 up to here, it's going to space these points out a little bit more. Right? It's going to give me more space. I want you to make whatever... Actually, let me double check because I think I might have some different data for you. I know, cute little bat, right? Yeah, so I'm just going to let you guys decide it on your own. I should have really printed this data, at least for your teams. All right, hold on, because we have like 3 minutes to talk, and then we'll come back to this tomorrow. Here's what you need to decide. What is your X and what is your Y? And how are we going to scale the graph? Please do not start packing up, because I have 3 more minutes left with you here. What I'm asking you to do is talk about this problem for a couple minutes before we pack up. How do you want to make your X and your Y? And how big do you want to make your graph? It feels like, because these are really close down here, feels like I don't need all this space up here, right? This feels kind of silly, but I don't know. You guys do what you want to do. Far? They probably updated their data. I'm not even joking. Like CPM a kid probably emailed and said, actually, I looked up the Brazilian bat and you're wrong. And CPM probably changed the book when they printed it. But this is like old, or vice versa. The book had the old info and this is new because I downloaded this like a month ago. So not quite sure why the book is different, but you can just use this number if you want. Use either number, just pick one. I don't care. Will everyone's graph look the same? No, unless we all choose the same scale. Oh, right now works if I can find something. You got a bag? Like, do you have your backpack with a pocket that we could dump these into? Or do you want a separate bag? Let's check out if you got a good spot in your backpack. What's in that front pocket? But then your friend might love you to get icers. That is so many. I forget what number you got. All right, now you may pack up and head out. Have a wonderful day, guys. By the way, did anyone lose a ring that looks like a kitty cat? Anyone lose a ring that looks like a kitty cat? Is it? So I wondered if it might be yours. It was found in the restroom by Zero, so you can thank them if you would like to.
Lucky.